So in the last video I made, a guy from Western Australia, Pete, he sent me a kilogram of this incredibly rich ore. And I did both a fire assay on it and a chemical extraction. And the fire assay showed about 50 ounces per metric ton. And when I tried to extract the gold from the ore, I got more like half of that. So in this video, I'm going to try to figure out how to get as much gold out of it as possible, being really careful this time with every step, checking, maybe doing fire assays on a fraction of the material and so forth. So let's see if we can figure out what happened and how to get as much gold extracted from this stuff as possible. So here's the half a kilogram I have left of this ore. It's been ground to 60 mesh. A few percent of it is larger than 60 mesh. You know, see the previous video for lots of details on that. Anyway, I'm going to remix it because I want to be absolutely careful that I get a fair and unbiased sample. So we'll put this half back, save it for another day, another experiment. And so that's the sample size that I'll be using today. Now let's weigh it up. So I'll be taking 120, let's make it 120, into a 500 milliliter beaker. And to that I'm going to add, say, 300 milliliters of 15% hydrochloric acid. And that'll help us get rid of lots of base metals that we don't want in subsequent processing. I had a lot of great comments on my previous video, so I'm going to take advantage of those comments and do things really carefully. So the first thing I'm going to do is I will not quite boil, but I'll keep this at 80 degrees centigrade for a couple of hours and extract all of the mostly iron out of the ore. It won't extract any of the gold, and then we'll have a purer material to start with. Okay, this is settled for about a half an hour. I'm going to filter it off. We'll test it with stannous chloride, and then I'll rinse. I now really like to use this style of filtration for almost everything. I have a wad of cotton in here. And this is a seal ring. You can buy them in a set on Amazon. I'll put a link to that. That seals into one of these vacuum port flasks. And I just pour the fluid in here. And this very silty material, it'll take some time to filter, but that's okay. No rush. The ore was reacted in hydrochloric acid. This is the filtrate. It's a little bit cloudy, but not too bad. And here's all the silt that I filtered out of the solution. I don't expect there to be any gold in here, but I'm going to check anyway. So I'm going to react this with Aqua Regia. And of course, this is the main source of the gold now. And I'm going to check this solution in a spot plate to see what I got, if I have any gold in there. So let's take some of this, put it on in a spot, and we'll add some fresh stannous chloride. I just checked this to make sure that it's active. Stannous chloride will last for a month or two in aqueous solution, but then it forms a hydroxide, so you have to be careful. After a while it won't react and you can really get fooled. Anyway, there's no reaction that I see there. Of course, this shouldn't have any gold in it at all, because all I did was dissolve that in hydrochloric. So no gold, so I think we're safe to neutralize and then discard this. Now here's a nice trick if you're looking for gold. In the bottom of a beaker, some beakers work better than others for this, but in the bottom of a beaker, just swirl the material and then let it set. And then we'll take a look at that under the microscope from the bottom up. So here's what I'll be using to take a look at that material. The cell phone goes in here. This is the magnifier, and it has a light source, so it'll go underneath there, attached to the cell phone, attached to the case of the cell phone. So, and then we'll put this up here and take a look at it over that hole. So there's no doubt there is a huge pile of gold in here. Of course, we knew that already. Of course, at this point, I would, if you were actually mining, you would remove the gold using a pan or whatever technique you want, and then process what remains. I'm going to process the whole thing because I'm interested to see how much of it I can actually extract. The next job is to dissolve the gold in Aqua Regia. I don't think there should be any gold in here, but I'm going to do it anyway just to find out. This is the main ore after cleaning in hydrochloric acid. So I will use some 15% hydrochloric acid, and then I'll use 10 milliliters of nitric in this one, and probably like 2 in this one. I'm going to do that with a respirator on because the nitric acid is really dangerous. Alright, well, I dissolved the gold in the ore and the silt for 2 hours. And I'm going to take a look at this under the microscope to see if there's any remaining gold. Now I'm testing the ore that's been digested in Aqua Regia. So the gold should be completely gone now. And it certainly looks like it. I'm going to kill off the nitric with sulfamic acid in both of these. And I'm going to do it with the respirator on because it's really nasty. And now I'll let that settle for a few minutes. Now I'm going to do a stannous test on the silt extraction. I want to know if there's any gold in there, if we have to proceed any farther with it. So that'll be a control, and that'll be the stannous test. So these are identical at the moment. And stannous chloride in this one. Nothing. So with stannous and without stannous, there's a little tiny bit of gold in there, but that's microscopic amounts, so I don't have to deal with that. So I'm going to say that there's really no gold in that, so all of the gold is still in here. So let's actually run a stannous test on that while we got it here. This should be, of course, loaded with gold. All right, so loaded with gold. Almost no measurable gold in the silt, so all of the gold is in that fluid, and anything left in the ore which hasn't been digested. So as usual, cotton in the filter, vacuum, rapid filtration until we encounter the silt. Tap water rinse. It'll take a couple of filtration cycles to get this clear, of course, because it's very, very silty material. While that's filtering, I'm going to take another look at the bottom of this beaker to look for gold. So let's go do that. Okay, so we're taking a look at the beaker. There's still quite a few sulfide particles in there, but not a single piece of free gold that I can find. The filtrate's a little bit cloudy for my taste, so here I'm filtering it again to try to remove as much of the silt as possible. I went through a couple of these filtration cycles. All right, this is sodium metabisulfite. Should drop the gold immediately. That's more than enough. Now this has had about a half an hour to settle and coagulate, so I'm going to filter it. Notice I'm using a much smaller funnel, that way I can use a smaller piece of cotton, and that makes it easier to cupel it in the end. SMB precipitates much larger gold particles than stannous chloride does. So it's greatly preferred. However, in small concentrations of gold, it doesn't always work, I found. Other people have found the same thing. So sometimes you have no choice. You either precipitate with stannous chloride or you precipitate with something like zinc or aluminum. As a result of filtering, I got to wipe that a little bit with some cotton. But all the gold is down in there, and I'll get it into my Cupel. Good. I'll wipe that out with some cotton. And I'll stick that in the oven at about 500 degrees Fahrenheit to dry it out first. Okay, so all of the gold should either be in that Cupel, or if there's any left in here, it could be in there. But let's make sure that there's no gold in this stuff. So we'll do a stannous chloride test of the filtrate. Even though they're perfectly clear, we'll run stannous into this one. So there's absolutely no gold in the filtrate. So far I've caught it all either in the Cupel or some remains in here. I mean, it's certainly not free gold anymore. It would have to be locked up in sulfides or something. There's the extremely beautiful bead. Pretty big bead. All right, so let's take a look at what we got. So from round one, which was in the previous video, I did a fire assay. I got something like 1,550 grams per metric ton. A huge amount of gold. This is a little over 50 ounces per metric ton. And I did a chemical extraction and I got a little bit less than half of that. So I screwed this up somewhere. And, you know, I discarded things before I actually got an answer, which is a very bad thing to do. I won't do that anymore. Don't discard your stuff until you're sure that it has no gold. So in round two, which is this video, I did a chemical extraction. I think I got all of it, and I got a whopping 2150 grams per metric ton. So there's a difference between here and here, which I'm not sure is actually so significant. The nugget effect is big, so it could be that more of the gold, you know, landed in the sample in this case than it did in this case. That's very hard to tell unless you do a whole bunch of, you know, samples. So if I do 10 samples, I could see what the distribution is. Maybe someday I'll do that, but that's a hell of a lot of work. Anyway, the conclusion here is that I think I got most of the gold from the chemical extraction. And so there's no longer, you know, a really big discrepancy between the two. It's an amazing piece of gold, and I want to thank Pete again very much for sending me such a incredibly high-grade sample of his ore. And thanks for watching.